Okie dokie. All right, so we were doing a problem. This is as far as we got, which is great. Starting with lesson 3. Write a quadratic equation in standard form with negative 1/3 and 6 as its roots. Okay, so here's a few things that are important to know. And this is probably what we were going to write, and then I was like, well, it's about to be spring break, and our time is up, and if we keep going, y'all are going to forget it all, and so let's quit. That's probably what happened. I probably said almost exactly that. And so, what are roots? That wasn't an actual question, it was rhetorical. They have another name, which I think is more useful and more informative. Another name for roots is zeros. Right. Another name for roots in this context is the x-intercepts.
Well, only in this context.
Yeah, because roots could be, like for a plant, right? Yes, of course. X-intercepts.
Which is how I was going to answer it until I decided better.
You could have done that. I might have laughed for half a second, or I might have made fun of you, depending on how I felt. It's fine. You're not worried about it. You're used to it. Okay. Yeah, totally fine.
Yes, sir.
Not, other people making fun of me, making fun of, whoever I feel like at the moment.
I just kind of that sounds like
See earlier comments. Okay, so those are what they are. Now, this is how to solve a problem like this. Okay? So, we have to use a theorem that says basically this. This is not quite what's in the text, but I think it's useful. Okay? There's a theorem that says if we have A times B equals 0, then we can say A equals 0, and we can say that B equals 0. Because one of them is definitely going to be 0, right? One of them has to be 0, right? So we can, in order to solve things and whatever else and do things that are useful, we can set them both equal to 0. And so what we're going to do is, to solve this problem, is we're going to do this. We're going to make 2 sets of parentheses.
Always how you start it.
Yes. Yes. Well, this type of problem, yes. Okay. And we're going to say equals 0. Right? Then what we're going to do is we're going to plug these in as bits. Now the one thing that's important is we have to switch the signs on these when we put them in parentheses. So it's got to be x plus 1/3 and x minus 6 equals 0. Now, this is in a factored form, which we're going to relearn and remember how to get it to that form in a minute. But to solve this problem and to get it into standard form, we're going to undo the factoring. Okay? So we're going to distribute it out, right? Easy peasy. We've seen this. We've seen FOIL. Everybody's seen this. Yes, we remember, sort of, kind of. Yes, no, maybe. Okay.
first outside, inside last.
Yeah, first outside, inside last, or it seemed like that's how I learned it, but then as I started teaching, it seemed like everybody else was teaching outer, inner, so whatever. Either way works. Right. So we're going to do the first times the first. So x times x, which gives us what?
Squared.
X squared. And then we're going to do the outside. So x times negative 6, which gives us negative 6x. Then we're going to do the inside. 1/3 times x is 1/3 x. And then we do the last, which is 1/3 times negative 6, which is what?
3.
Negative 2, yes. equals 0. Now, the one other thing, well, there's two things. One is we can clean this up a little bit. And then another thing that's important is that I think we're going to take care of first is in standard form, you can't have fractions. So we got to get rid of the fractions. We got to make them disappear. No, that's still a fraction. Decimals are fractions. So are percents. Okay. That's not what I mean by no fractions. I mean no partial numbers, period.
There you go.
Okay. Okay. Ooh. Sound like a sound effect from like a Sega Genesis game. Ooh. Okay, so how are we going to get rid of the fraction? What can we multiply times everything to make the fraction go away?
3 trays.
3. That's right. So essentially, we're going to distribute that 3 onto everything. Okay. So 3 times x squared is what?
3x squared.
3x squared. That's right. And then 3 times negative 6 is what?
18x.
Negative, right?
Well, that's the fastest I've ever done math.
You're doing great. And then 3 times 1/3 is? Yeah, 1x, yes, x, yeah, all true. And then negative 2 times 3 is? Negative 6.
And then
Equals 0.
0.
Yep.
Because every time.
So we can do one more thing to clean this up. What's that one more thing? Yeah, combine like terms. Okay, so we're going to bring down what we're not combining, right? So 3x squared, and then negative 18x plus x is? True. And then bring down our minus 6 equals 0. That's the answer. There's an equation in standard form with those roots. Sound gooch so far?
Now we have to clean it up.
It's cleaned up. It's done.
Yeah,
It's finished.
but like, I mean, you can clean it up further if you want. It's just
How could you clean it up further?
way you can.
You cannot clean it up further.
Without solving it. You can.
Yeah, you could solve for x at this point, and you would get these as answers, which we're going to talk about very soon. But in order to solve it, you got to kind of go in reverse and get back to that.
That's one way to check.
But which we're going to do in a minute. It would be one way to check it, sure, that's true. Okay, let's do another example. Hey, we're going to do this one as a guided practice, which means, in case we forgot, that I'm going to write it up here, you're going to do it, I'm going to do it with the screen off, and then we'll all check together, right? So, we're going to have the same instructions, but the roots are now going to be 3/4 and -5. Ready, go. This is what I'm reaching for. There is the problem. Any questions on that problem?
Oh, yeah, I got it right.
Oh, good. Well, check what you've done so far if you're still going for some reason. And see if you can see the path to victory. And if you understand it, or if there's a part that you're confused about.
But no, it's right because I remembered to subtract and not add. Why is it?
I'm pretty sure that my answer is correct because I did it independently and matches what the book says. So if I and the book agree, then it's probably right.
I would have done it right
But-
if I didn't forget the negative on the 5.
That,
So
yeah,
I added the 20 and the 3 to make
Gotcha.
it negative 23 instead of 17.
yep. What?
Why is it all multiplied by 4?
Because I'm trying to get rid of this fraction
Okay, so you just multiply,
by the least common denominator. Yep.
Oh,
Which
get rid of the fraction.
you did 15/4. I just did 3.75, and I still.
that's fine. Yeah, it's the same thing. I mean, you probably, but if I did it this way, then I can do it in my head instead of
It's
needing it.
also faster.
It is, but that's okay. That's totally fine.
It would have saved
Yeah. Often on many problems at this point in your math career, at this point, it is very often wiser to leave it as an improper fraction until you do something with it later. Because often it's going to be easier to get rid of the improper fraction than it's going to be easier to get rid of something else. So you don't have to take that advice. It's just often easier. Okay, so let's do example 2. See, now they talk about the zero product property, which is what I just told y'all a minute ago, but I don't know how they expect you to understand why you would do that without that then. So whatevs. I teach it now. Okay, example 2.
Wait, why is that all equal to 0?
Which one, girl?
The whole thing.
Because of this? We're gonna do the reverse in a minute. It might make more sense when we do the next example. If it still does it, then come back. We'll circle back to that question again. Okay. So example 2. Okay. So our instructions are this is example 3. Example 3. This is example 2. But problem 3, depending on whether you're using the old numbering system or the new one. That's fine. I've told y'all that repeatedly. They're your notes within reason. You have to include the material. The organization within reason is up to you, as long as there is, organization. Okay, so the instructions are solve. Okay, and the problem is 16x squared plus 8x equals 0. So we are solving this using factoring. That's the whole title of the lesson, right? Right. Okay. So this one we're going to factor using our good old friend GCF. In fact, you pretty much should always, and by pretty much I mean you should always look for GCF first. Okay? That should be your first look when you're solving for any of these quadratics, right? Is look for that. So, what is in common between the two terms that we have? 8x. Right? 2 is as well, but it's not the greatest, right? Yep. Okay. So we're going to pull an 8x out, right? And then when we do that, we're going to write down what's left. So, and by doing that, basically you're dividing that term by the thing is really what's happening. So when we take 8x out of the first term, what's left? 2x, not squared because we're taking an x out. So just 2x. If we're dividing this one by 8x,
It's the x as well.
so what's left on the second term?
1.
1. It is 1. Equals 0.
Technically, just take out an 8. Would just leave you with an x. Which is why.
You'd have to solve it a different way if you did that. But on this problem, you could still solve it with that.
2x.
But you want to take out the greatest common factor, though, because it's going to be easier.
2x.
Okay, so once we have this factored, we're going to use this property right here. And to finish solving, now that we have a quadratic that is completely factored, there's no plus something else out here, right? Or minus or whatever else. And equal to 0, which is what we have. Then we're going to take and we're going to split this into 2 problems. And we're going to set each factor equal to 0. So we're going to say 8x equals 0 and 2x plus 1 equals 0. Right? And then to finish out, all we have to do is solve each one of these little baby equations, which shouldn't be all that hard. So what are we going to do to solve this guy?
X equals 0.
It does. Why? What are we doing to get there? Divide by 8.
I don't know, man. I was using logic.
No, you're using math.
Yeah,
Math
it's
logic.
really quick math, so it seems like you're
Yeah, but it's
logicking.
It's logical math.
yeah.
But he didn't know how.
Well, since logic is math, I guess we could say that, but it's not all. Yeah, I don't know. We're getting into things.
Logically, x equals 0, but I just didn't do any math to prove it.
That's actually totally true. You're doing algebra to prove it. Math is too general. If we're gonna make some weird semantic argument, which we are at this point, we have to be very specific with our terminology, because semantics. What should we do on this guy? You did though.
Well, I did afterwards.
Subtract 1.
And then
Divide by 2. X equals -1/2.
yes, it does. So if we were to write this problem the other way around, if we were to write this like example 1 and guide and practice 1, then we would create an equation write an equation in standard form that has the roots 0 and -1/2. And we could go back and get that equation that way.
Oh, okay.
So now, what if there is 3, like, a full standard form equation at the top? How is the number x squared, then the one with the regular x, and then the regular number?
We wouldn't be just factoring with GCF. We're headed there.
Cool.
Okay. So let's do a guided practice. This would be GP2. Let's do this one. 4y squared plus 16y equals 0. Ready, go. Oh. Whoa.
Oh.
Exciting.
I didn't hear what you said.
Whoa. Oh, look, it killed it. Good job. So proud. Wow. Oh, I guess I should hit the right button, huh? Windows K. Which also a.
Can I just change those y's to g's? Not g's, x's?
No.
No, it has to
It
be
will
y.
work with my brain better.
No. You gotta expand your brain. That's like the main point of doing algebra.
What happened?
What did I do now?
I don't know the PlayStation.
Why all?
It's in a different spot though.
Okay.
Working with us today.
Freeze. Okay, that's what I'm trying to do, and that's what you're trying to do. Ready, go. Good Lord. Good Lord. This is where we should have ended up.
Yeah, I was almost there.
Why there should be open forums for example.
Okay, so it sounds like we have questions, so, ask them.
What happened to the squared, that y squared? Why did it disappear?
Because you divide it by the greatest common factor. Our greatest common factor is y, right? Or 4y. So we're dividing by 4y. Y squared divided by y is y.
What? Wait. What happened? Oh, okay.
No, your answer's right.
I didn't
If
know.
it's y equals 0.
I accidentally kept the y on the 4.
Oh, yeah.
How do you
That's what I got.
You'd have to factor it again.
So I just had to combine them and then
So you would have gotten 0, 0, and
yes.
-4. Which you can have duplicates. We'll learn what that means later. But okay, so any other questions on this problem? What?
I got it.
All right, good.
Just seeing if I could do it. I got it.
Okay. How did we did? We did good? Okay. All right, let's do example 3. What?
Wow.
Whoa. Are you good? Okay. Example 3. Is x squared equals 64. What I really want to do is to do this twice and to do this 2 different ways, which is not quite what they did in the book, but I think it's valuable for you to see both of these things.
That way you can do it whichever way you think is better.
This is example 3.
Whoa, what is happening here?
I just said what's happening. Okay. So one method, the first method, since the title of this lesson is solved by factoring, is we're going to solve it by factoring. Okay. So in order to solve a quadratic, and I alluded to this earlier and said it out loud earlier, and the first thing that needs to be true, which is not true yet, is it needs to be completely factored, and what else? Equal to 0. So we've got to turn this into a 0 over here, right? So we've got to subtract 64 from both sides to turn that into 0. So this cancels. Okay? So we end up with x squared minus 64 equals 0. Now, it's been a while since our unit 0 and even longer since your Algebra 1, and some of you only did about half of that, so you didn't see it then anyway. So, to remind you, what we do now is what we have here is we have a difference of 2 squares. Right? Okay. X squared is a perfect square, and so is 64. Right? To remind us, because I feel like eventually I always have to remind people of this, what are perfect squares? Let's list them down to a few things here. So what's 2 times 2? 4. So that's a perfect square. What's the next perfect square? 9, because that's 3 times 3. What's the next perfect square? 16. And then 5? 25. 36. 49. Yeah, that's right. It's 49. And then 64. And then
Which is the maximum of items you can carry in one stack.
81. And then 100, right? And they would keep on going, right? Forever. Etc. Yeah. Right? Okay, so these are both perfect squares, and it's a difference. So it's a difference of 2 squares. So to factor a difference of 2 squares, it's super easy. Does anybody remember how to do it? Well, it has something to do with that, yes? So first step, step 1 is 2 sets of parentheses. Open, close, and we bring down our equal 0, right? And then just like in a trinomial factoring problem, there are 2 slots. First, outside, inside, last, right? There's 2 slots that are happening here. In the first slots, we put the square root of the first term. So what's the square root of x squared? X. We put x and x. In the second slot, we put the square root of the second term. What's the square root of 64? 8. And then we do a plus and a minus. That's right. So now we've got something that's completely factored and equal to 0. Right? And so we set each factor equal to 0, x plus 8 equals 0, and x minus 8 equals 0. And there it is. And then we solve and finish it out. So minus 8 over here, minus 8 over here, plus 8 over here, plus 8 over here. Those cancel. So we end up with x equals negative 8 and x equals positive 8, right? So that's one way to solve this problem. It's a perfectly valid way to solve this problem. Another way to solve this problem, which is technically faster, but you have to remember something important.
Do it correctly.
Okay? So when we're trying to get rid of something in an equation, we do the inverse to get rid of it, right? We do the opposite, right? So what's the opposite of squaring something? Square root something. So we can get rid of this squared by square rooting both sides of an equation.
Which would be x equals 8.
So the square and square root would cancel. So x is here. Now, the thing that you have to remember is that when you take the square root of both sides of an equation, the answer comes out as plus or minus that thing. So what's the square root of 64? 8, right? So our answer is plus or minus 8, which is exactly what we got over here. Okay?
It's much easier.
What?
Exact same thing, it's just we didn't
Quicker than the other one.
Yeah, and it's a useful skill because we see it useful in other places too. So it's good for you to see both.
It was my first answer to this problem as well.
All right.
First looked that up, my brain was like, oh, that's 8. That's the one thing I can do quickly is square roots.
What an interesting problem, which has nothing to do with that example. Oh, but that does. That's a better, yeah. Here's our guided practice. I found it. I don't like, never mind. Well, it depends. This class, this year, I don't like that example right now. But we'll do it in a minute.
That's sad. I want to do that problem.
We will in a minute.
Don't be like that.
Just not yet.
Yeah, see?
So guided practice 3.
Great person 3.
81
I'm also a little bit older than 3.
x squared minus 9x equals 0.
81. Or 8L.
This is not a system, so there's only one variable. Okay, ready to go. There's 2 different ways, theoretically, to start this problem. I'll do it both for you, so you can see them both.
Cool.
Y'all only have to do it once. Keep hitting the wrong buttons.
Button presser.
The answer, while I refix this stupid thing, is 0 and 1/9.
What? Oh, okay, I see. I just did it badly.
Okay.
Like I did the problem right, I just also did it wrong.
That doesn't make sense. If you didn't get those as answers, then you did it. Then you didn't. One of those.
Where'd you get negative 1?
Oh,
Oh.
right, of course.
Because 9x divided by 9x is 1. And negative 9x divided by 9x is negative 1. Yeah. Good questions. Question?
No, I figured it out.
Okay.
I did it right, I just didn't do it all the way.
Didn't finish it.
Yeah.
The first way I wanted to do it would not.
If it doesn't end up as x equals something, you did it wrong.
Yeah.
When the instructions are solve. If the instructions are simplify, very often you'll end up with all kinds of gobbledygook. But if the instructions are solve, you should end up with one or more number answers, theoretically. Yes.
If I was to do it the way you thought I was going to do, what would you have to do?
You can't really solve it that way. Assuming that what you did was take the square root of both sides to begin with. You can't really do that. You have to,
X on 9, right?
yeah.
Because it's not square.
Well, and you can't really do it that way to begin with either because of the minus 9x. Like if you had moved the 9x over and taken the square root of both sides, you could get to the answer. It would be more annoying because then you'd have to undo what you did at some point and like you'd just end up going in circles for a little while. But you could theoretically do it if you did that. But you could not solve it taking the square root of both sides right now. You could then square both sides to literally just undo what you literally just did. But other than that, you could not solve it. It's not possible to do it that way. Okay.
I wonder if the majority of Nordic people were left-handed.
Okay, so we're going to remind ourselves.
Greens are written, they're all backwards from what we would normally write.
Many languages have backwards like sentence structure. So I don't know. Example 4.
Well, their letters.
Yeah, backwards compared to what? Yes, valid point.
What is this example?
Their letters
4.
face left, our letters face right.
Are you stressing over there? You know you can number it however it makes you feel comfortable.
I'm trying to keep up.
Because they're right.
This is example 4.
Section.
Our instructions are still solve. Okay.
And a couple of their letters are just.
The problem is x squared plus 9x plus 20 equals 0. Okay. So we have a quadratic equation. It's equal to 0. So what we need to do in this lesson is factor it, because if we get it completely factored equal to 0, then we can split it and we have a happy day, right? So what we have here is a trinomial, which we've done before this year. It's been a while, but we have done it before this year, okay? So how do we go about solving this or factoring this left side?
You can't do greatest common.
There is no greatest. That is good that you should look for first. Absolutely. There isn't one, but you should definitely always look because it'll make the rest of it easier if you take that out first. So what's next step? This is the step that this next step is the one that I said you should all be able to remember. If you can't remember at least this step after we are reminded, of course, then you're like, I can't help you on a quiz or a test if you can't even remember and get the points for this very first step. That's right. Look at you see.
Nice.
Good job. I don't even have to remind because you reminded. 2 sets of parentheses. We bring down equals 0. So we do guess and check method, right? Okay. And I call it smiley face method. So what we do is the first thing is we do the first, remember it's the same slots as with the other, right? In the first slot, we do 2 things that can multiply to get the first term. The only options are x times x on this one, right? It's the only thing that's possible to get x squared.
I remember this and like it.
Okay. So x and x. Well, I suggest practicing it well because in order to pass the TSI, you have to be able to factor pretty much because it's everywhere.
Let's do 3
That's
times
just
3.
like, you said that the last 4 classes, so I think it's in our brains.
I hope so. Okay. So now, the next slot, we need 2 things that multiply to get 20. So let's list our different factors of 20.
5, 2 times 10.
So what did you say? 4 times 5, 2 times 10, 1 times 20, right?
It's 4 and 5.
Those are the Yes.
5 is.
Yes. Yes, yes, yes.
Yeah, we all know it's 4 and
Okay.
5 because it adds up to 9.
So we're going to put a 4 right here and a 5 right here. Now, to figure out our signs, we're going to smiley face with. So we got a nose and we got a mouth, right?
No, I remember that.
So 4 times 1 is 4, and 1 times 5 is 5. So in order to either add or subtract to get the middle term, what do the signs need to be? Plus, plus. So then we follow our smiley face back, and we add our signs. It literally doesn't matter because they're the exact same. So we put a plus right here, and here we put a plus, right? So now we have something that is completely factored and equal to 0, yes? So now what's our next step going to be? Same as we've been doing. So what do we do?
X plus 4 equals 0 and x plus 5 equals
That's right. And x plus 5 equals 0. And then we subtract 4 and subtract 5, and we end up with x equals -4 and -5. That's right.
easy peasy.
Easy peasy lemon squeezy. How we doing? We hanging in there?
That was vaguely simple.
That's more or less true.
For that one,
Yeah.
Let's squeeze in one more example
cool.
before I say homework.
No. And you just said it, so.
Slap a fool.
So we gotta
Okay.
do the homework. Not the example. Oh well.
6y squared minus 23y plus 20. What? Yep. Equals 0. So it's a trinomial. So we're going to trinomial factor it, right? But we're going to look for GCF first. Is there a greatest common factor? Other than 1, of course.
No, yes.
Yes. No.
It's 2.
No, because 23.
There's not.
I am so dumb.
Just 1. Yeah, that's it. It's the best we got. Right? So we're going to head straight into our double parentheses, right?
So yes, there is like one.
Okay. So now it's a little bit trickier if you remember when A is not 1. Because it's not just going to be Y and Y. We have, in fact, different options.
It's gonna be 2 and 3.
2 and 3, yeah.
Okay. So, mother of pearls. We have 2 and 3, and we also have 1 and 6. And for 20, we have the same as, excuse me, before. 5 times 4, 2 times 10, and 1 times 20.
I feel like it's most likely gonna
Okay.
be 5.
So we got it. So for the first lot, we just got to pick one. So you want 2 and 3 or 1 and 6?
2 and 3.
2 and 3. Sounds great. Let's try it. So 2y and 3y. What is it we're going to pick for the next slot? 5 and 4. That sounds great. In that order?
Yes.
Okay, so let's try it. 5 and 4. So now we're going to smiley face and see what happens. So 5 times 3 is 15. 2 times 4 is 8. And we're trying to get a negative 23. So can we do that with those signs? Can we add or subtract those things and get the signs?
Both have to be negative.
Negative 15 minus 8. And then a negative times a negative at the end gives us a positive, so it works all the way around. So we follow our lines up, and we put a minus, and we put a minus. And then we have 2y minus 5 equals 0, and 3y minus 4 equals 0. So our answers are y equals negative 5 halves and 4 thirds. Questions on any of this stuff?
What if they weren't the same sign?
Then you would fall. So, like, if it was, that's a good remembery question. Yes, absolutely. So, if this had in fact been what we got, right? Then you follow your nose up, and this one would be plus, and this one would still be minus. So you're following the smiley face to get the signs and where they go. Because negative 5 times 3 is negative 50, or is, excuse me, positive 5 times 3 would be positive 15. Negative 4 times 2 would be negative 8, right? The answer in that, if it was that case, it would be no. The what? The answer for the actual problem is that. Negative 5 halves, positive 5 halves. Sorry. It's what I get for rushing at the very end. Trying to get us out the door more or less.
That's what happens when you're rushing.
It is. I used to joke, my wife and I, when we were first married. When I was probably around y'all's age, maybe a little older, I had a crush on this Russian lady. Unfortunately, she was also married, so that was never going to work, and older than me. And I may have, I don't know. But I used to, we joked that I wanted to marry a Russian. My wife said, well, you did. I'm Russian here and Russian there. Have I told you that story before?
Yep.
So cute. Page.
0.
I didn't remember the punchline though, so I'm good for that.
Nice. Oh yeah, I love this plan. Page 244.
I don't think I like that.
Numbers 18 through 48. 18 through 48 evens. Guten bye.
2 foot full. Alright. 18 through 48.
Stop virtual camera. Well,